Alright, section 2.3 is on page 103, talks about rates of change. The book talks about velocity and marginals. We're going to focus on marginals, of course. Velocity has the same concept, but on a different application. So, three things we're going to be using all throughout this course. One of them is P is going to stand for total profit, R for total revenue, and C for total cost. Now do remember, cost has two branches. It has fixed plus variable. Revenue is sales, total sales. And I'm going to talk about that in a minute. We have a formula for that right there. Revenue is the demand. How many pieces do you want to buy? Times, if X is the price, times X. And profit is always the revenue minus the cost. So how much are you selling for? How much it cost you? The difference is the profit. Now marginals are figuring out their derivative of these quantities, derivative of the profit, derivative of the total revenue, derivative of the total cost, marginal profit for profit, marginal revenue for revenue, marginal cost for cost. They call this dP dx, assuming x is the number of units, or P prime, dr dx, or r prime, or dcd. Just need to move that a bit. I'm kind of squishing those in. I thought I had enough space, but I didn't, so here, much better. And if I take C prime, which is the rate of change instantaneous at a given point. So marginal cost, marginal profit, marginal revenue is at that moment how much is it varying with respect to the number of units you're selling. So the number of units X, that's how it's going to be in this book, that consumers are willing to purchase at a given price, P, is given by a demand function. The tricky part is that the demand function is not some D. The demand function is given as a function in terms of X, and they call it P, price. The price depends, the demand depends on the price. The total revenue is then related to the price and the quantity by revenue is the number of units times the price per unit, and that should give you the total revenue. So how many units do you want to sell, and what's the price for each unit? You multiply those, that's revenue. Something you need to remember. Sometimes they give you the revenue function, sometimes they don't. But this here is the price function slash demand, and we'll talk about that when we start playing with the functions. So for now, they're giving us what those are. So here we are. Let's talk about those and interpret this a bit. Find the marginal cost of producing X units. X is the number of units and the cost is in dollars. So C is in dollars and X is the number of units. Well, you take a derivative. Derivative of a constant is 0. That's 21x squared. What does that mean? Once we get into numbers, I'll elaborate on that a bit, and we could pretty much clarify what those are. If I look at number 22, the same deal. If I say what's the, you could say C prime, I don't mind. 100 is a constant, you ignore that. That's 0 plus 3. Isn't this x to the 1/2? Don't you bring the power down? Subtract 1 from the power. So wouldn't you say this would be 100 times 3 over 2 radical x? So tell me what x is. I'll plug it in and I'll tell you the marginal cost at that point what's the additional cost of introducing the next unit, depending on how many units you want. And just to be clear, this is not linear. It's not like the first 10 units are going to cost you the same as the last 10 units. That's not true. The more you make, the less your cost becomes. Alright, how about marginal revenue? Well, it's the same idea, really. There's not much here, just making sure that you know how to do the calculus. Take a derivative, that's 30. Take a derivative, that's 2x, and there it is, done. Now radicals are not going to go away. So here, you could distribute if you want. You could leave it as is. It doesn't really matter. You could say 50 is a constant. Derivative of this is 20. Bring the power down, subtract 1 from the power. So that's actually 50 into 20 minus 2/3 the square root of x. Again, without numbers, we're just practicing derivatives. I was going to give you the first set of problems from number 1 and on, but I thought, since this is what we're going to be doing, might as well let me just tackle that head on. And here is a marginal profit. This P is for profit. There's P for price and P for profit. They'll be very specific. It says find the marginal profit of selling X units. Well, the change in profit for selling X units is bring the power down. That's 50. Of course, you could use a calculator. Plus 2,000. And if you want to tackle number 30, you will say dp dx or p prime. That is negative 1.5x squared. Bring the power down, subtract 1 from the power, minus 164.25. And there it is. So the calculus is really simple. The interpretation is really what we want to pay attention to. So let's start with number 32 and start looking at what all of this means. So the calculus is going to be the tool you're going to use to really get all of these awesome applications cleared. I'm going to write this as, so I'm going to distribute that in 1800x plus 64x squared minus 2x cubed. Part A, which is the calculus. Find the marginal revenue. How do you find marginal revenue? You take the change of R with respect to X. Derivative is 1800 plus 2 times 64, 128x minus 2 times 3 is 6x squared. When selling 14 units, I need my calculator. Luckily, I have one of those, and here it is. What is 1800? And what did they say the price was? How many units? 14 units. So the marginal revenue, and I'll tell you what that is now that we are looking. Oh, there is no x there. Plus 128 times 14 minus 6 times 14 squared. I'm getting $2,416. Evaluated at x equal 14, I'm getting $2,614. If I want to interpret that, I really have to put that over 1. Remember, this is the change in units. It's very important that you understand this. This is the change in revenue. It's saying by the time we are selling the 14th unit, you should expect for each unit at that time you're making the revenue is increasing. If it's positive, it's increasing roughly $2,614 for every unit that you sell. This could be a fridge, this could be an oven, whatever it is. In part B says find the additional revenue when the number of rentals increase from 14 to 50. Oh, actually, it says what it is. I'm sorry. The revenue from renting X apartments. I'm sorry. So this is a function. How much would you collect from renting apartments? This is saying by the time you rent the 14th apartment, for each at that time you're making roughly 26.14 in revenue for each unit that you rent at that time. And here they want to confirm that. They say, find the additional revenue when the number of rentals increase from 14 to 15. So, part B is saying, what is the revenue of renting 15 apartments minus the revenue of renting 14? Wouldn't that be the one from 14 to 15, around 14? They're trying to see how close is it to that number. And here my calculator will come in handy. Do keep in mind, I just need to worry about the revenue, not the derivative, the revenue. So the revenue is going to be, let's see how it works. 2 times 15 times 900 plus 32 times 15 minus 15 squared minus R of 14, the same function, 2 times 14 times 900. Oh, I could have used this also. I don't know if that's easier, right? Here, I'll use that for the second one. For the second one, I'll use 1800 times 14 plus 64 times 14 squared minus 2 times 14, oops, wrong key, cubed. Okay, something didn't go right at all. Let me see what that is. Oh, crap. Let's do it again. Let me see, can I recall it? Nope, it didn't register. Okay, let's use this. So I have 1800 times 15 plus 64 times 15 squared minus 2 times 15 cubed. Okay, minus, oh, I use parentheses, minus 1800 times 14 plus 64 times 14 squared. Yeah, last time I did subtract this, I use parentheses, minus 2 times 14 cubed. 2394. $2,394. So this is saying, if you were, instead of renting 14, if you were to go from 14 to 15, you're making extra revenue for that one apartment, $2,394. Calculus got it in no time to be roughly, was it 26? Oh boy. I cleared it. Was it 2614? I think that's what it was. 18 plus 128 times 14 minus 6 times 14 squared. Yep, 2416. I was going to say this is a bit bigger. 2416. So look at that. 23. So they're only $20 difference about. Right? I'm sorry. $22 difference. But hey, that's pretty good compared to the exact. But that gives you a very good idea. That's part C. You notice the difference between those. If you take that minus 2394, you're only off by 22. So these are very close. And that's where calculus comes in very handy. It turns out it's very hard to figure this out, especially if you want to get an idea. Calculus allows you to do that in no time. And here we are. So remember, price is revenue minus cost. Revenue, if they give me the demand or price function, revenue is the price times the number of units times X. Now, I'm not saying it's going to apply to this problem, but here we are. So I'm looking at this problem, and this is what it says. It says when the admission price for a baseball game was $30. When the price was $30, 36,000 tickets were sold. Very good. When the price was raised, when they increased the price to $35, only 32,000 tickets were sold. Assume that the demand function is linear, which means it's a straight line, right? Assume that the demand function is linear. Demand is linear. Well, this is the price, this is x. So first we figure out the slope. The slope is y2 minus y1 over x2 minus x1. Uh, 5 over, what is that, 32 to 36,000. Divide by 5, divide by 5, 1 over 800. And if I take this and say y equal 1 over 800 x plus b, 30 equal 1 over 800 times 36,000 plus b. So 36,000 divided by 800 is 45. So b is a negative 15. So my equation becomes p is the price. I used y, I'm so used to y. P. The price is 1 over 800x minus 15. So, find the profit function. I just got the demand function. The demand function states the price is 1 over 800x minus 15. When they say find the price or the profit, we know how to do profit. Profit is revenue minus cost. Profit is revenue. Well, let's talk about revenue. This is the demand function. How do you find the revenue? Revenue is x times the demand function. So that will be x times x over 800 minus 15, or simply x squared over 800 minus 15x. Minus. Now let's talk about cost. The cost function. I knew something was wrong. I can figure out what it was. 32,000 minus 36,000 is negative. That should be negative right there. That should be negative 45. So that's a positive 75. Oh, my numbers are off. When you add 45 to both sides, that's 75. I got those backwards. I'm like, it's not working. Why is that? Because I made a mistake. So this is negative and this is positive. Negative and positive. And if you distribute this in, that becomes a negative x squared plus 15x. Now, how about the cost function? Let's figure out the cost function. The cost, it says, assume that the demand function is linear and the marginal fixed cost, and the fixed cost, and the marginal and fixed cost. This is the changing cost and this is the fixed. So the cost is, the marginal is 5 times each of those tickets plus 700,000. So 700,000, like to rent the place and do all of these things, and the 5 is the cost for producing those tickets. So in this case, the profit function is negative x squared over 800 plus 15x minus 5x minus $700,000. So that would be negative x squared over 800 plus 10x minus 700,000. That's the profit function. So that's what you need to get first. Okay, I forgot to make that a 75. And that will be 70. Part B, we're going to skip on here on the homework. It says find the marginal profit when 18,000 tickets are sold. Find the marginal profit. Well, what's the marginal profit? The change of profit with respect to x. Bring the power down, subtract 1 from the power. So the marginal profit is negative x over 400 plus 70x. Right? So when they say selling 18,000, you will say dp dx at 18,000. Since I'm going to do that a few times, I'm going to use the answer key. First, I'm going to put 18,000, and now I'm going to take negative answer divided by 400 plus 70 times answer. And let me make sure. Oh, that's a big number. And the problem is right there. Again, that was a very large number here. When I take a derivative of this, you bring the power down. Isn't the derivative of 70x just 70? So if I go in there and I go back, and delete that right there. Now if I go for 18,000, and if I go to what I stored, negative 18,000 over 400 plus 7, I'm getting plus 70, I'm getting 25. And did they say what the function is in terms of? Well, let's see. They're talking about profit of x units per $100. Okay, so that's $25 over. The top is dollar, it is dollars, and the bottom is per one ticket. Per ticket. So when they are selling 18,000 tickets, they're making roughly at that time, at the 18,000, $25 per ticket. And how much are they making? How much is the marginal profit changing at 28,000 tickets? dp dx at 28,000 and 36,000. So it's only a matter of plugging these numbers on my calculator, but what does it mean? 28,000 okay. Where's that formula? There it is. I'm not liking that. Let's do it again. 28,000 0. I'll tell you what that means in a minute. And how about 36,000? Negative 20. Per ticket. Okay. Now how could your profit be 0 and how could you be losing money? Well, keep in mind, if you really look, keep in mind that the demand function, right, depends on the price and the number of units that you sell. So if you want to increase the number of tickets, you have to lower the price, right? Those go hand in hand. Here, whenever this is increased, the price is lowered, and when the price is lowered, obviously the revenue, the profit is lowered. So at 18,000, you're doing very well. You're making roughly $25 per ticket. For you to be able to sell 28,000 tickets, then at that point, your profit is diminished because your price has to go down. Remember, you have a cost with this. And if you try to sell 36,000 tickets, at that moment, you are roughly losing $20 per ticket. And we'll elaborate on that a lot more in the problems to come. I gave you an even problem, and the answer to the even problem is right there, number 38.